Okay students, we'll try to understand how to find out square root of a complex number. As you know, complex number in general is written like this. It has a real part, and this part written with iota is known as imaginary part. So if you are given any complex number, how to find out its square root? Let's take an example and try to understand. Suppose we have to find square root of this complex number z, which is given as equal to iota. It also means we can write like this. So real part of this given complex number is 0 and imaginary part is 1. Now we can assume the square root of z is equal to another complex number. Okay. So we are supposed to find square root of z, and I have assumed square root of this complex number is another complex number having x as a real part and y as an imaginary part. So we will try to find out values of x and y, then we'll have the final square root as required. Okay. Now what we can do is we can square on both the sides in this equation. If we square both the sides, we'll be getting iota equal to, this can be written as, now as iota square is minus 1, this is what you get. Okay. Now we will equate real parts on both the sides. So equating real parts on both the sides, I'll get 0 equal to x square minus y square, which also means x square is equal to y square. Okay. Now equating imaginary parts on the two sides, left hand side and right hand side, we'll get 2xy equal to 1. Okay. Now we can use an identity. This identity we'll use. So I'll put the value of x square minus y square, which is 0, and I'll put the value of 2xy from here, which is 1. So this gives me x square plus y square equal to 1. Okay. Now using this condition 1, x square equal to y square in equation 3, using 1 in equation 3, in place of y square I can write x square, as x square and y square are equal according to equation 1. So this gives me x square equal to 1 by 2. Okay. Now according to equation 1, x square and y square are equal, so the value of y square would also be 1 by 2. Okay. Now let's evaluate further. We got x square as 1 by 2, so x can be written as plus minus 1 by root 2, and similarly y would also be equal to plus minus 1 by root 2. Now the square root required, square root of z, which we initially assumed as x plus iota y, can be obtained if we put the values of x and y carefully with the signs. To decide the signs, this equation 2 will be helpful to us. This equation says x into y is equal to 1 by 2, which is a positive number. So as x into y is equal to a positive number, it implies x and y both are positive, or x and y both are negative. In these two possibilities, the product x into y would be a positive number. So possibility 1 would be square root of z is equal to when x and y are both positive. So 1 by root 2 plus iota into 1 by root 2. That can be written like this. This is one possible square root. While possibility 2 would be when both are negative. Okay. So this is the possible solution. The square root of z, which is iota as given in the equation, would be either equal to this or would be equal to this. So we can write root z equal to root iota equal to plus minus 1 plus iota divided by root 2. This is the answer. Okay. Let's take another example. Suppose z is given as minus iota and we have to find square root of z. So we'll assume square root of z is another complex number, x plus iota y, like we did in the previous example. So we'll focus on finding x and y. We'll follow similar steps now. We'll square on both sides. If you square on both sides, you'll be getting minus iota equal to x plus iota y whole square, which should be equal to this. Now on the two sides, the left side and the right side, we'll equate real parts as well as imaginary parts. If we equate real parts, we'll get x square minus y square equal to 0. Okay, and if we equate imaginary parts, we'll be getting 2xy equal to minus 1. These are the two conditions obtained. Now we'll use the same identity as we used in the previous example and put the values. This is 0, 2xy is minus 1, that gives me 1. So x square plus y square would be equal to 1. Okay. Now if we use equation 1 over here, equation 1 says x square equals y square. So using equation 1, I can rewrite this as 2x square equal to 1, x square equal to 1 by 2, which is also equal to y square, as x square and y square are equal according to equation 1. This gives me two possible values of x and two possible values of y. Now we need to carefully decide about the signs. Here if you see x into y, the product is negative. So as x into y, this product is a negative number, it implies x and y must have opposite signs. If one is positive, other is negative. If first is negative, second must be positive. Okay. So the square root of z, x plus iota y, can be written as, if I take positive value of x, I'll have to take negative value of y. Second possibility, I'll take x as negative and then I'll have to take y as positive number. Okay, so you can combine these two and write the final answer, square root of z, which is square root of minus iota, as 1 minus iota divided by root 2, and put a plus minus sign to consider both the possibilities. Okay. Okay, let's try another example. Here complex number z is given as minus 7 plus 24 iota and we have to find its square root. So we'll take square root of z as equal to another complex number x plus iota y. Okay. Squaring on both the sides will give me minus 7 plus 24 iota, and right side should be this, as done in the previous examples. Now we'll equate real parts on the two sides to get one condition, and we'll equate imaginary parts on the two sides to get the second condition. Okay, now we'll use the same identity as we have been using in the previous examples and put the values from equation 1 and 2. This is minus 7 and the second 2xy is 24. This gives me 49. The two add up to 625. So x square plus y square whole square is 625. So x square plus y square is 25. This is my equation 3. Our focus is to find values of x and y and put here, that would be the final answer. Okay, so I'll add equation 1 and equation 3. This is equation 1 and this is equation 3. When we add, we'll be getting 2x square equal to 18. That gives me x square as 9, x equals plus minus 3. Okay, now if I put the value of x square, which is 9, in any of these equations, equation 1 or equation 3, we'll be able to find value of y square. So I'll put x square equal to 9 here. that will give me y square as 16, which implies y is plus or minus 4. We got the values of x. Now we have to decide about the sign. Here x into y is equal to a positive number. Because x into y is a positive number, it implies either x and y both are positive or both are negative numbers, so that the product x into y is positive. Okay, so one possibility, square root of z is equal to when both are positive. So I'll take positive values, 3 plus iota 4, and second possibility when both are negative. So we can combine the results and write square root of z is equal to this. Okay, thank you.